Okay, let's start the next problem. Consider the following code fragment. Okay, so this is some code fragment, and if fork is equal to 0, then do this. So what this code is saying, that if this fork call, so you're making a fork system call out here, and if what is returned is 0, then you execute this code. Otherwise you execute this code, this piece of code. Okay, so it's kind of a decision thing. Okay, if 0, do this. If not 0, do this. And then let u v be the values printed by parent processes. So you have your parent processes, they print u and v. So why do you have your parent and child processes out here? Because you're making a fork call. So when your parent code is executing and it makes a fork call, then what happens, it splits into two parts. Okay, there's this parent is there, it will run, and then there's this code, this child code also. The exact copy of this code is there in child, and that child also runs. Okay, and for parent you have this u and v values that are printed out here. Okay, so that means this a and ampersand a. For in both the cases we print a and ampersand a, so that is we print a and address of a. Okay, in both the cases out here, and those are printed, so those must be parent or child, whatever. Okay, and for child you are printing what, x and y. Okay, then you have to tell which of the following is true. So just one thing that you probably know about fork call is that, so when it splits into parent and child, okay, all the code is copied to child, it returns a value. Okay, it returns 0 to child. Okay, so it returns 0 to child, and it returns the process ID of child to parent. Okay, that's the difference between this fork system call that is in between the child code and the parent code. So the value that is returned to child is 0, and the value that is returned to parent is the process ID of the child. So, and when we say that if this thing is equal to 0, then we do this. So that means that this part of code is executed by the child. Okay, and this else part is executed by the parent. That's what we can know for sure. So which means that this things becomes u and this things becomes v. Okay, and this things becomes x and this things becomes y. Okay, another thing. Okay, so in the beginning both this children and parent, okay, they share the same memory. Okay, memory is shared in the beginning. That's important. As you create this child process, the memory is shared, but once you start writing in some variable, okay, you make this write thing. Okay, you are writing a, you're assigning some value to a. Once you start writing, the memory is no more shared. Okay, later separate memories. Okay, or address space, you should rather say, the memory allocated, rather you should say. So later what happens is that they get separate uh, memory allocation. So they are on different parts of memory. That's what you can think from here. Okay, when you make this right thing. So that's it. So now we can analyze that what is happening out here. So for this child you are increasing the value by 5. Okay, and for this parent you are decreasing the value by 5. So that means that for this child the value of a will be more, and for this parent the value of a will be less. And how much will be the difference? The difference will be of 10. So this tells you that your x will be greater than y. Okay, because for child you have x, so that means that x will be 10 greater than u. Why? Because out here you increase by 5 and out here you decrease by 5, so total difference is 10. So which is the case with C and D. Okay, that is the case with C and D. So that means you can only eliminate options A and option B. A and B are gone, you're left with C and D. And then what it talks about is whether V is equal to Y or V is not equal to Y. And what are V and Y? Are these addresses. Okay, and you know that once you start writing somewhere, the memory is no more shared, they get separate memories. Okay, the memory allocation is they get different parts of memory. So suppose parent is running in this section of memory, the child is running in this different section of memory, and with that thing you know that these addresses must be different, and that means that the option D is correct.